Let's start the next topic for the chapter hydrogen, that is metallic hydrides. In the previous classes, we have discussed about the ionic hydrides and the covalent or network hydrides. Next is the metallic hydride. So metallic hydride. What are metallic hydride? So most of the D block elements, that is transition elements, that are generally termed as transition metals also. Okay, and F block element forms the metallic hydrides. They form the metallic hydrides on reacting with hydrogen. Among the D block, the group number 3 to 5, okay, from the elements of the group number 3 to 5 forms commonly hydride, commonly hydrides. Okay, in group 6, only chromium is the metal which forms hydride. Okay, chromium is the metal which forms the hydride. And from group number 7 to group number 9, the elements does not form hydrides, and hence this particular groups of elements is termed as hydride gap. Okay, this particular group is termed as hydride gap. Okay, generally the example for the metallic hydrides are, the general example for the metallic hydrides are scandium hydride, scandium hydride, yttrium hydride, yttrium trihydride, lanthanum hydride, lanthanum trihydride, titanium hydride, zirconium hydride, hafnium hydride, etc., vanadium hydride, etc. So here the general formula, the general formula for the compounds is EH2 and EH3 for the hydrides. Okay, so this is the general formula for your compound which is found out by hydrides from the metals, that is EH2 and EH3. Next, beryllium and magnesium of S block also form. Okay, so beryllium and magnesium also forms the hydrides which are from the S block elements. Okay, and hydrogen rather in this both these compounds, when beryllium and magnesium are forming the hydrides, they are generally forming the compound in the molecular form, that is they are having the covalent nature as comparison to that of the ionic nature which are formed other by other S block elements. Okay, and we will also see that the hydrides which are formed here, okay, these are the hydrides which are formed here by the metals here, they are generally interstitial hydride, interstitial hydride, interstitial hydride. They are interstitial hydride. Okay, and this interstitial hydride of metals is formed due to that are formed due to small size of hydrogen atoms as compared to the metal atoms. Okay. So we can compare that as the interstitial solid solution. Also, we can make them we can represent them as the interstitial solid solutions. Also. Generally, the examples for interstitial solid hydrides, metal hydrides are palladium hydride. Okay, which is an example for the interstitial hydride. Platinum hydride, it is also an example for the interstitial hydride. This is the example for your interstitial hydride. Now let's see the characteristics, general characteristics of metallic hydrides. General characteristics of metallic hydrides. So in this, they are hard. Metallic hydrides are generally hard, have a metallic luster. They will be having metallic luster, can conduct electricity, and have significant significant magnetic properties. Significant magnetic properties. Number two, the densities of these hydrides are lower than those of metals. Okay, the densities of these metals are generally, the densities of these metal hydrides are lower than those of metals from which they are formed. From which they are formed because the crystal lattice, the crystal lattice expands due to inclusion of dihydrogen. Okay, it will expand due to inclusion of the dihydrogen. Third, these compounds are non-stoichiometric. Okay, these compounds are non-stoichiometric and their composition varies with temperature and pressure. Means when on changing the temperature and pressure here, we will see that the densities of these compounds will be changing out. Okay, the compounds of titanium and zirconium, okay, is generally having this kind of nature. Next, fourth, they give out they give out hydrogen easily, hydrogen easily, and act as strong reducing agent. and act as strong reducing agents. Okay. The F block element, that is lanthanoids and actinide hydrides. Okay, the F block hydrides, elements hydrides that are also non-stoichiometric. Okay, they are also non-stoichiometric hydrides. For example, La 2.87, YBH 2.55, TBH 3.07, etc. They are also having lower density. They are also having lower densities than metals, than their respective parent metals. Metallic hydrides can be used as hydrogen storage media. Okay, they can be generally used as a storage media for hydrogen. Okay, and can be used as a source of energy for vehicles. So these were the metallic hydrides. Next, let's discuss about the water, which is one of the important compounds formed by hydrogen. So water is one of the essential part of the organic life. It is one of the most common and abundant, easily obtainable chemical compound of hydrogen, and it is termed as one of the universal solvent. Okay, it is termed as the universal solvent, and many chemical compounds are studied or researched on the basis of water only. Okay, water is used for their study generally. Water consists about 65% of human body. Okay, it is the 65% of the human body, and on earth we can say that about 70% of the earth is covered with water, and 1% of that is about of drinking condition, that is fresh water, and the other water is in the form of saline water in the oceans. So what is the structure of water? So the structure of water. First, the chemical formula for water, it is H2O. Two hydrogen is combined with one oxygen, and the structure of water is bent or V-shaped, or it is also called as angular angular structure. So here the structure of water is oxygen. Here oxygen is combined with two hydrogen in this form, where one OH bond is equals to, okay, one OH bond is having the bond length of 95.7 picometer, and two lone pairs will be present for the oxygen. One will be here like this, and one, okay, two lone pairs of oxygen will be there, and the angle between the bonds here, it will be 104.5 degree. Okay, which is lesser than that of the normal bond angle for the tetrahedral structure, that is 109.5. Okay, and this is due to the size of the hydrogen. As the size is smaller of the hydrogen is smaller here, therefore the angle between them is also smaller. Next, hydrogen bonding in water and ice. So water is polar in nature. Polar in nature. We know that water has a polar nature, that is the oxygen and hydrogen present in the water possess a very small amount of charge there. Okay, it will be possessing very small amount of charge there. Okay, so water is polar in nature. Okay, and due to this reason, what will happen? Negative and positive charge will be prevail on hydrogen and oxygen after the bonding also. After their covalent bonding also, they will be prevailing positive and negative charge. And due to this reason, they will form. Due to this reason, they will form hydrogen bond. Intermolecular hydrogen bond will be found out. And the hydrogen bond for water, it will be something looking like this: del negative charge, H, del positive, which is connected to other. So one second, it will be something like this, and each oxygen is having like this. They will be having the bond here. Next, H, OH, then again it is forming a hydrogen bond, H, H. Then again here this H is forming bond with O, and this H is forming bond with another oxygen there. Similarly, this H is forming bond with O, again with O. Okay. So like this, the structure of the water will be there after forming the hydrogen bond. Okay. But in case of ice, okay, but in case of ice, the structure here it will be like this. Okay, it will be forming a web-like structure. Okay, a web-like structure, and due to the formation of this web-like structure here, due to the formation of this web-like structure, we will see that they are having the vacant spaces there. Okay, they will be having vacant spaces, and this is the structure. This is the hydrogen bond for ice, and due to this reason, the density of ice will be lower as compared to water. Okay, it will be lower as compared to water. So hence we will see that the ice will float on water. So ice is nothing other than the solid form of water, and in the other cases we will see that the ice is the solids of the liquids are having more density, but in case of water it is having lower density. Okay, so this is due to the formation of hydrogen bonds in the case of water and ice, which is making them lighter. Okay, which is making them lighter. Next, physical properties of water. Physical properties of water. So first, water is liquid at room temperature. Its freezing point is 273.2 Kelvin, and its boiling point temperature is 373.2 Kelvin. Next, the density of water. So water's maximum density is 1.00 grams per centimeter cube at the temperature of 404 degrees Celsius, that is 277 Kelvin. Next, water contains strong hydrogen bond. Water contains strong hydrogen bonds in its molecules in its molecules and and exist as associated molecules. Okay, all the molecules there, it will be in the associated form and they can be represented as H2O(N). Water is polar in nature. Water is polar in nature. I have discussed this thing before also, that what is polar in nature due to presence of positive and negative charge over oxygen and hydrogen. They are due to high electronegativity of oxygen there, and the dipole moment of water is 1.84 d. Okay, and due to this reason, it has high solubility. Okay, it will be having high solubility, and is termed as universal solvent. Universal solvent. Let's see the chemical properties of water. Chemical properties of water. Number one, stability of water. So water is a quite stable compound. Water is a quite stable hydride of oxygen, and it does not dissociates. It does not dissociates into hydrogen and oxygen. Okay, at very high temperatures also. The high negative enthalpy. The reason here is that it is having very high negative enthalpy of formation, which is 285.9 kilojoule per mole. Okay, and it starts decomposition at 1500 Kelvin. Okay, it starts to decompose at 1500 Kelvin temperature. So gaseous water starts to decompose at 1500 Kelvin temperature into hydrogen and oxygen gas. However, by electrolysis also we can decompose the water. Okay, by passing a very small amount of current with a very small amount of alkaline water there. Okay, very small amount of alkali to be added in water there. On passing an electric discharge or an electric current through the water there, we can decompose the water there. But generally water in the on increasing the temperature, it is very highly stable. Means thermally it is highly stable, but on electrolysis we can easily obtain the hydrogen gas and oxygen gas. Okay, so hydrogen gas will be obtained at the cathode and oxygen gas will be obtained at the anode. The second chemical property of water is the amphoteric nature of water. Amphoteric nature of water. So the amphoteric nature means when water is reacted with base, it will act as acid, and when it is reacted with acid, it will react as base. Okay, so means it is possessing both acidic and basic nature. Okay, here the protonation of water, if we are undergoing the water as protonation, here we will found that it is forming a hydronium ion and a hydroxide ion. Okay, a hydronium ion and a hydroxide ion will be formed out there, and the water dissociation constant is 10 to the power minus 14 mole square liter square at room temperature, that is 25 degrees Celsius or 298 Kelvin. Okay. So water can, due to this reason, due to the formation of hydronium ion also and hydroxide ion also, water can easily, okay. So due to this reason, we will see that water can behave both as acid and basic. So with HCl, on reacting with HCl, water will form hydronium ion there. Okay. So water here is acting as a base, and with the H2S also, water will be behaving as a basic substance only, and it will be producing hydronium ion, which with HS minus. Okay. So this is the basic nature of water. This is the basic behavior of water. And for seeing the acidic behavior, when water is reacted with ammonia gas, okay, ammonia at aqueous solution, there NH4 plus OH minus aqueous will be formed out. Okay. So here we will see that the water is behaving as an acid. Next is the oxidizing and reducing nature of water. Okay. Next is the oxidizing and reducing nature of water. Oxidizing and reducing nature of water. So water can both, okay, water can act as both oxidizing or reducing agent. Okay. So as an oxidizing agent, if I am seeing water as an oxidizing agent, we can take an example here. Water liquid will accept two electrons to form 2OH minus and H2 gas. Okay. So due to this reason, due to formation of OH gas here, OH here, when it is been reacted with sodium metal, the water will produce NaOH. That is, oxidation of sodium will take place. Okay. It will be acting as a oxidizing agent. It will be acting as a oxidizing agent. Okay. One more example we can see. When carbon is reacted with water and at 273 degree Kelvin temperature, in the presence of nickel, carbon monoxide and H2 gas will be produced out here, which is termed as water gas, okay, or syngas, okay, SYN syngas, okay, at 1273 Kelvin, sorry, not 273 Kelvin, 1273 Kelvin. It is termed as syn gas, SYN syn gas. Next, water as an reducing agent. As a reducing agent, so O2 gas plus 4H aqueous solution plus 4 electron will produce 2H2O liquid. Okay. So hence the water can act as a reducing agent also. Here we can take example for two molecules of difluorine. When reacted with water, it will form chloride ion and hydronium ion with oxygen. Okay. Similarly, when carbon dioxide is reacted with water in the presence of sunlight and chlorophyll, the photosynthesis process occurs and formation of glucose takes place. Okay, so formation of glucose is also the nature of water, showing its reducing nature. Okay, next, hydrolysis reaction. Water produces hydrolysis reaction. When metal oxides or non-metal oxides are reacted with water, so it forms either bases or either acids. Okay, it will form either bases or either acids. So I have taken two examples here, which is forming one sulfurous acid. Okay, in case of non-metal oxides, when water is reacting with non-metal oxide, it is producing acids. Okay, and in case of metal oxide, it is producing bases, that is hydroxides. So this is the nature of water, that it will on hydrolysis reaction it will produce different kinds of acids and bases. With the metal oxides it will produce bases, and with the non-metal oxides it will produce the acids there. Similarly, with carbides also, with metal carbides also, on the hydrolysis of metal carbides, bases will be formed, and with the metal hydrides reaction with the water, metal hydrides reaction with water, there the formation of the formation of bases will be taken place. Okay, so this is the hydrolysis reaction of water with other compounds, binary compounds. Next is the hydration reaction. Hydration reaction. So water has strong ability to form compounds with metal salts. Okay, they can combine with metal salts to form hydrates. Okay, they can combine with the metal hydrates to form hydrates. For example, Ni2S plus 6 molecules of water will form metal salts that are termed as metal hydrates. Okay, similarly, chromium hydrate, iron hydrate, etc. are the examples of the hydrate salts which are formed by the metals. And this type of nature of matter is termed as of water is termed as hydration property. Okay, hydration reaction of water. Next, water molecules can form the crystallization of water when combining with the crystals of salts. Okay, so here this particular water molecules which are known as the hydration of crystal or water of crystallization, this type of nature is also been observed by the water. This is termed as the water of crystallization. Also, water molecules can be combined up in the interstitial spaces by some of the salts, such as in case of BaCl2. Okay, there it is present in the interstitial space of the BaCl2, and there it is being combined. So therefore, they are termed as interstitial hydrates. Here they will be termed as interstitial hydrates. And in case of formation of crystals, if the water is participating in the formation of crystals, then it is termed as the water of crystallization. Okay, then it is termed as water of crystallization. So for today, I am ending the class here only. We have studied about the chemical and physical properties of water and the metallic hydrides in this particular class. In the next class, we are going to see the heavy water and the hydrogen as a liquid fuel. Okay. So for today, I am ending our class here only. We will meet in the next class. Thank you.